Miss Block here, and today we're going to talk about metamorphic rocks. While watching this video, make sure that you have your ESRT, your Earth Science Reference Tables, handy. Maybe turn to page 7 where all the metamorphic rocks are. You also want to have maybe your metamorphic rock vocabulary sheet and look at all the beautiful vocab related to metamorphic rocks. As always, you can pause or rewind or review this video to make sure that you truly understand the concepts. Are we ready to rock and roll? Let's get started. So, as we've been discussing, minerals are the building blocks of rocks. And there are 3 distinctive types of rocks: igneous, sedimentary, and metamorphic. Now, we can't use composition to classify igneous, sedimentary, and metamorphic because they often have many of the same minerals in common, since there are so few minerals that are known as rock-building minerals. So instead, we need to look at their method of formation or their origin. So exactly how do metamorphic rocks form? Metamorphic rocks are rocks that form through intense heat and pressure. So if we were to look at the rock cycle diagram that we have on page 6 of our Earth Science Reference Tables, you can look right there at this little rectangle and you can see how a metamorphic rocks form. Now, unlike an igneous rock or a sedimentary rock, which can't directly turn into because if you want to turn into a sedimentary rock, you first need to be weathered and eroded into sediments. If you want to turn into an igneous rock, you first need to turn into magma, and then you can solidify into an igneous rock. Metamorphic rocks, you can go directly to that type. You just need to have heat and pressure to have that metamorphism. So what happens is we'll take an original rock known as a parent rock. In this case, we have sandstone and shale acting as parent rocks, and then they'll metamorphize under that heat and pressure, depending on the conditions, into a new rock. So right here, we have some sandstone under heat and pressure will turn into quartzite. Right here, we have some shale, and under some intense heat and pressure will turn into schist. And we're going to talk a little bit more about this metamorphism in a little bit, so stay tuned. Right here, we can see granite turning into gneiss. Granite, as you recall, is an igneous rock, and it has many intergrown crystals. That's what these rectangles represent, the individual minerals in the granite intergrown into each other. It's just random without any rhyme or reason. However, when we apply a stress on that rock, also known as pressure, the minerals will start to realign and reform. So we have something known as foliation or mineral alignment occur. It might appear that this sample of gneiss, a metamorphic rock, has some layers, but they're not like the layers that we'd find in a sedimentary rock. A sedimentary rock would have continuous layers, while in our metamorphic rock, the layers are not continuous. They're disjointed and disformed. Now, when we look at our metamorphic rocks, we tend to separate them first by texture, whether they have that foliation like we saw with the gneiss, or if they don't have any foliation like we saw with our quartzite earlier. We're going to focus first on the foliated at the top. And as we can see here, we go from less intense to more intense, and we'll focus in on this again. So if we were to look here, we have our sedimentary rock shale, and as we apply heat and pressure to it, it becomes more and more metamorphized. So slate has not as much heat and pressure applied to it, say as this sample of gneiss. At the bottom, we have our non-foliated metamorphic rocks, such as this sample of quartzite right here and a sample of marble. Did you know what the parent rock of marble is? It's limestone. Good to know. Now, we have 2 distinct types of metamorphism. Contact metamorphism occurs when molten rock, like magma in an igneous intrusion, comes in contact with surrounding rocks. All right? This is through heat, and it's over a much smaller area than, say, regional metamorphism. And we'll talk about regional in a little bit. So if you were to look right here at this diagram, we have an igneous intrusion with some magma. And as it comes in contact with some shale, quartz sandstone, limestone, we start to have some changes to those rocks around it. So, since we're having that heat that shale will change into hornfels. Our quartz sandstone will turn into quartzite. Our limestone will turn into marble. So you'll have an igneous rock here, you'll have sedimentary rock here, and then inside you have your metamorphic rock. Indicated here is which rocks we can see that will change by contact metamorphism. I highlighted them for you. And also, in case you forget how these rocks change, contact tells you in parentheses right here, just through heat. Regional metamorphism occurs over large areas, like during continental collisions. Not only do we have heat during this time, but we also have increased pressure. So if we look in this diagram here, you can see large, continents colliding into each other, and it's causing a lot of heat and pressure to change the rocks that are there. This would happen over a very large scale. That's why you'd often find metamorphic rocks in mountainous regions, like the Adirondacks are made up of metamorphic rock. So if we look right here, we can see at the top that we have regional located here. And as we go from the top to the bottom, we have least intense metamorphism to the most intense right here. So slate is not as metamorphized as much as gneiss. That's why gneiss not only has foliation with the banding that we saw earlier. We can also see regional metamorphism at the bottom with some of our non-foliated rocks. Make sure you can notice these observable characteristics of metamorphic rock. Foliation is big, all right, just like in this schist right here and this schist right here. We can also sometimes have banding in our mineral alignment. So our schist also has mineral alignment, but we have banding in these two right here, and we have these distorted layers apparent. Right? So if we look right here again, make sure that you're understanding that the mineral alignment, the banding, look at these comments because they will let you know what the parent rocks were for our various rocks here. So often they might ask you, like, what was the parent rock maybe of marble? And you can look right here and see that it's limestone and dullstone. You might need to know what the parent rock was of anthracitic coal was, and we can see it was right here, bituminous coal. This is very helpful with many other aspects. I hope this was helpful. Again, any questions? Watch it again, bring them to extra help, review your vocabulary, and I'll see you real soon. Take care.